Now, there are certain principles that I apply when I set up my iteration loops in order to be as tight as possible. And one important principle is the principle of isolation. Whenever I'm setting up my iteration loop, I aggressively isolate. And this means many different things in many different areas of the work that I do. For example, if I'm working on some data problem, and in that data problem, I have a very large set of data, I do not run my analyses on the entirety of the set of the data because honestly, most of the time in the initial steps, the mistakes I'm going to make are trivial or superficial or obvious when performed on just one data element. So you'll see whenever I'm mapping something out, you'll see breaks or you'll see islices. I'll operate on the smallest possible representative data set in order to see, did I do something just completely pointless? Did I misspell eig? Is it eigen instead of eig for computing the eigenvalues? And once I'm satisfied with what I have, then I remove those breaks and then I say, okay, now it seems to work. Oh, it doesn't seem to work on this particular data item. I narrow myself down to that item and then go on. It is very, very tempting to try to run all of your code on the entire data set that you'll actually operate on. I know I have wasted so much of my life doing that, but whenever I remind myself, no, I want to move quickly, I always think about how do I reduce the data set that I'm operating on as aggressively as possible. So for example, if there was an error later on here, for example, I've got 3 of these, maybe if I had 30 of these, in the 29th of these, it might be very tempting for me to say, oh, that's just a tiny error. Let me just keep running this main loop. And then it'll pop up on the 29th issue. Maybe I got something wrong mathematically, but that is not the right idea. What I really should do is I should subset this down to the erroneous element and then get it working on the erroneous element, and only then do I lift that back up to all of the elements. Otherwise, I'm just going to be wasting my time and I'm going to be loosening that iteration loop to my own detriment. When we talked about things like web scraping, you would have seen some other tricks that we have used. For example, I recently did a presentation that made use of this third-party library, Y-Finance, that allows you to pull data from Yahoo Finance. And as part of that presentation, I pulled some option data. Now, you can think that I'm already doing a pretty bad job of my iteration loop if I do anything moderately complex because making those HTTP requests to Yahoo Finance are going to take time. And it's very likely that if I do this across many tickers, it's going to take quite a bit of time before I can even try to do the analysis I want to do. And so, obviously, I'm going to narrow myself down to maybe looking at one ticker initially, and then only once I'm satisfied, look at maybe another ticker, see if there's any errors, and very carefully and judiciously move to looking at the full data set. But even when I'm looking at just one ticker at a time, these 2 calls are actually still fairly slow. They're not incredibly slow, but you can see that there's still maybe a half a second there. And so any additional analysis I do on top of this is already pushing me into the territory outside of slower than the speed of my action. How do I solve this? Well, while I'm solving this, one other thing I can consider is, what is the downside to discovering that I've gotten rate limited by the API? In fact, isolation is not just about isolating the data set, it's about isolating you from the rest of the world. Do I really need to be running the live query every time I run this iteration loop, every time I test something? Absolutely not. Because I could get rate limited. I could discover that maybe the API has changed. I'm just over a release of that API, and maybe the API change is very subtle. Maybe it's not that important. Maybe they renamed a column of the pandas data frame that they return. Whatever the case may be, is that something that I want to have to worry about? Notice that that confounds my analysis. I've set up a hypothesis. This is the way to perform the analysis. I test that. I quickly come back to my starting point, but I discover something went wrong. Is that the thing I just tested or some outside factor? And so I not only want to isolate myself down to one data element, but I want to isolate as many factors of the outside world. When we did web scraping, one of the things that we suggested you might do in order to prevent yourself from being rate limited by the web scraping or prevent yourself from running into other problems is to use some conceit like this pickle cache, where this pickle cache gives you the ability to decorate a function and to transparently pickle that function such that subsequent calls to that function read from the cache as opposed to read from the live API. It turns out that this actually works fairly well if I were to create a new cache here. You can see the very first call is slow, but the subsequent calls are fast. Actually, to make this a fair comparison, I really should print these out individually because the print will block. So here we go. So let's give this a new cache name. And we'll see the first call will be slow and the remaining calls will be fast. And then every subsequent call after that is now reading from that cache. When working with this Y Finance API, I might try something like that, but I'm going to run into trouble. Here, if I try that by, for example, subclassing their Y Finance ticker object and putting that pickle cache on this method that I anticipate to be the slowest one, I'm in trouble. My motivation here is a good one. Generally, whenever I'm trying to isolate, I want that isolation to be something that I can drop in and out of. Something like a break that I can comment out and then recomment. This is why I maybe more commonly might use a break as opposed to something like an islice. Imagine the difficulty of turning an islice on or off is actually quite hard because I have to either change this line here or remove it. I might even, if I'm doing like an islice, rewrite the header so that the way to turn this on and off is like that, or pull that out to a separate variable. But the reason I wouldn't pull this out to a separate variable is I actually want the isolation to be something that's transparent to my code. I don't want to pull it out to something and then end up with code that I wouldn't otherwise have written. So the intuition here is actually a pretty good one because the code is exactly the way I would have otherwise written it. It's just the case that I'll comment this out when I'm ready to look at the real result, but unfortunately it just doesn't work. And it's not going to be that uncommon for me to discover that some libraries just won't work with these typical conceits. What I'll need to find is an alternative conceit that preserves all of these principles. A core message here is the following. The actual tools matter much less than your use of these tools and your consistent use of these tools. If you see some of these tips and tricks and tools that we share with you in this session and you immediately rush off and integrate all of them into your work, it is very likely to be the case that you will not truly integrate them into your work, but instead very superficially use them and then discover that it's more painful than the approach that you had and in the end not really improve your process. In general, I shouldn't overly fixate on tools like this pickle cache. Instead, I should fixate on what is it gaining me. It's gaining me the ability to transparently turn some code that is blocking my iteration loop by doing too much work into some code that speeds up that iteration loop by removing that extra work and removing that extra dependency on something that's happening in the outside world. Now, I can dig around with this here, and I could try and rewrite this as like an option chain function, but this is not how I would write this code in the end. I wouldn't write a Python function called option chain just so that I could put a decorator on it, and in the end, it doesn't even work. And so I really don't want to change the way in which the code works. I want this to be transparent. And so what I might end up doing is I might end up doing something like writing another context manager, something very simple here that gives me the ability to take the original code the way I would actually write it. This is how I would actually write this code. And to transparently add just a little bit of detail to it, this context manager here that was written just for the purposes of this example, that gives me the ability to skip if it's already cached or to save this thing. This is a little bit clumsier than my original pickle cache. And it's definitely the case that I could improve it, but what's important here is that the tool itself is not what I'm focusing on, it's what it gains me. It gains me the ability to write the code the way I otherwise would, but then to isolate the portions of the code that I'm paying attention to as I iterate on, for example, the inner portion of this comprehension syntax in order to access the different option chains for every maturity for this particular option from this Y Finance library.